Welcome to our video today, still on numbers theory, and now our focus is on using Bezo's lemma to solve a linear Diophantine equations. A Diophantine equation is an equation of the form ax plus by is equal to c. I think that marker is not so clear. Let me use this that ax plus by is equal to c, where A, B, and C are all integers, where A, B, and C are integers. So, in that simple sense, for us to do this, we need to have a reverse of our previous example, which was on Euclid's algorithm. So, let's take an example. Given the question to find the values of x and y, find the values of x and y in 16x minus 28y is equals to 4. So, how do we begin to do this? We need to rearrange this because it's already written in this form. Write it and solve it using the Zoo's lemma. But we need to begin first with Euclid's algorithm. Now, let's see how we can do that one. So, first, using Euclid's algorithm, let's find the GCD of 28 and 16. So, find first the GCD of 28 and 16. That will be beginning with the larger number as usual. 28 is equals to 16 times 1 plus 12, because if you divide 28 by 16, the answer will be 1 and then remainder 12. Then let's pick the bigger number now, 16, which should be 12 times 1 plus 4. The next bigger number here between 12 and 4 is 12. So you pick 12, divide by 4, that will be 4 times 3 plus 0. So we automatically implies that the GCD of 28 and 16 is 4. So we need to work out from here the GCD of 16 and 28 is equal to 4. So with that, we can start solving this problem in the reverse. How do we do it? Now let's look at it from where we have the GCD. Automatically we have 16 is equals to 12 times 1 plus 4. So if we use the additive inverse of 12, and then we will have it as negative 12, so that we have that 4, this 4 will be equal to 16 minus 12. Now, let's call that equation 1. Now, let's go to the next equation. In this case, we have that 28. That 28 is equal to 16 plus 12. Now, since we have 28 is equal to 16 plus 12, I am omitting the 1 because that 1 tells you that the coefficient 16 is 1. So let's leave it at that point for now. See, it's still 1. So that automatically means that 12 is equal to 28 minus 16. So let this be equation 2. And we are going to substitute equation 2 into equation 1 for 12. So that 4, I'm writing this again, is equal to 16 minus, we are supposed to have 12. I will now put 28 minus 16. Okay? So what I'm going to have here will be 16 minus 28. Minus times minus is plus. And so we now have 16 plus 16 is 2 times 16. That will be 16 times 2 minus 28. 28 is just 1. So we bring our 4 down. So if you look at this question now and what we were given to solve, they look alike. So if I want, I will rewrite what we were given. We were given that 16x minus 28y is equal to 4. So if I rewrite this, we are going to have that 16 times 2 minus 28 times 1 is equal to 4, which now implies that x is equal to 2 and y is equal to 1. So you can see how solving from Diophantine equation from Euclid's algorithm and then taking it back to Bezout's identity has given us a solution to the Diophantine equation we were given by the question. Thank you so much. Don't forget to share, like, and then subscribe.